Now, we are going to graduate from ER diagram, ERD, and then we are going to move into relational data modeling diagram, or relational data modeling, or relational data design, whatever you call it, right? These are all phrases that describe this diagram that we're about to learn. Now, ER diagram, again, as I mentioned during the very beginning of the semester, that you would use ER diagram anytime you want still, but a lot of time ER diagram is the best way for you to conceptualize your app or conceptualize your program into relational sort of, tabular sort of structure of SQL databases, right? So it's something that you don't need to know about primary key yet. You don't even need to know anything about data type. You just need to know about what are some of the actions and how they're combining in the verbs. That's the diagram. It's the easy tool at the very beginning, the first thing to think about when conceptualizing app, features, MVPs into database tables. Now, relational data modeling diagram is a little more intricate. And we're graduating from ER diagram for that purpose, because now we know tables better. We also do know data type they are in SQL. We also now know about primary keys and foreign keys. And these are things that you will need to indicate or express in your relational data modeling diagram. Okay? Previously, ER diagram, you really think about is just actions, relationships, and diamond shapes and whatever shapes. Now you have to know about the names, data types, relationships, keys. Okay? So thinking about when we're talking about relationship, obviously we need to learn, or we need to come back and think about more is the cardinality. What is the cardinality? You should, when you're designing your database, start thinking about the relationship type. Is it a one-to-one cardinality or one-to-one relationship? Or is it a one-to-many relationship, many-to-one relationship? Or is it a many-to-many relationship? That's what cardinality means. Okay? So let's look at this 4 examples. Employees and departments. Okay, so one-to-one relationship here. A employee manage a department. Let's say if there's only one boss. I think this here will be better to explain using the employee as a boss, let's say. So department boss or head of department manage department, right? And the department is managed by the department head. And relationship here, therefore, is one-to-one. I think the employee is a little confusing. Let's say the head of department. Okay, publisher supplies books. Okay, this relationship here. Can one publisher supply multiple books? Yeah. Yes. Can one book be from multiple publishers? No. So it's a one-to-many relationship, right? It's not one-to-one because the publisher can have published many types of books, right? So this is obviously a very clear one-to-many. Now it says one and then sometimes you might see one and the other side is M, mother M. That's fine as well. Okay? Many-to-one is just a vice versa for previous one. So the book has sections. And one single sections or multiple sections is in one book. Okay? I'm actually not really sure if these examples are that great. So it's a little borderline. Anyways, Last but not least, many to many relationship here. Okay, can a student take multiple courses? Can the course has multiple students? It's many to many relationship here, right? Are these clear? Anybody confused? Any questions? Okay, so these are the 4 types of cardinalities for ER diagram. Let's move that into what it will look like in data modeling diagram. Okay, what it will look like in relational data modeling or relational data design. It will look like this. 1-to-1, they call it crowfoot. Instead of having 1 and an M or 1 and N or M and N, you're now drawing in the crowfoot area. It's kind of like the wrinkles around your eyes. 1-to-1 is, so basically what's missing here might be weird. So basically there will be another, it will be a table here, another table here. So you're drawing a line to connect them and showing 1-to-1 relationship by drawing just one single line. Okay, what's missing here you don't see is table here and table there. So 1-to-many is one single line, and this cross feet over here, like a little cross. Okay, and many-to-many. All right. Now, optionally, sometimes you do see this type of things. That in addition to this one cardinality, there's this one additional 0, or sometimes it's another bar. That just means that you giving the clarity of that table. Can there be nulls? Like, can there be a complete can the primary key there, can it be complete? Not there. So versus 0 is nullable versus if it's a bar, it cannot be a null. But this is completely not optional, right? So for example, can a puppy has a parent? Oh, that's not, that's a sad story. Can a car has no engine? No, right? So basically, if it's not, then you must, on the other side here, you must always put another bar. That's what it basically what it symbolizes. It's just telling us an extra clarification, but it's optional to tell. But what's not optional is this first one here, the first cardinality. Okay. All right, so then look at with the table. Let's say on the left hand side is customer, on the right hand side is transaction. So in this example, it says customer can have make multiple transactions, right? So let's say they place a lot of orders, so there's multiple transactions. So the transaction here would have the foreign keys of the customer, whatever primary keys is, right? All right, but then I've added an optional, again, this optional, I'm not going to take any points off if you don't draw this, it's fine, is that can I allow my table to have a customer created, but there's no transaction in my database? Yes, because yes, I'm going to allow the customer to sign up first, and maybe I don't need them to place an order on this at the same day. That's fine. Okay, so that's what this is. The extra over there is meant for. Okay, so before we go, so let's look at closely in our example here. Now, this is using draw SQL. If you haven't already used it. Now, let's take a look. The difference here is that using draw SQL, they somehow skip the parts that has 1. The 1-to-many, they skip the part with the 1 bar. I'm not sure why, but they're the only one that does this. So, but this tells you, this is giving you sort of an example of how the simple data modeling diagram looks like, right? So you can see that there's cardinality over there, and these are all 1-to-many relationships. Okay, so other than the relationship, let's come back and look at the one that we're a bit more familiar, other than the cardinality. Look at on the table, it has the not so naming convention correct, but still, there's still table names over there, right? At the very top, you must have a table name of each table. Now, you have all the columns of each table, right? You see the column there? Okay, so assignment has 3 columns. Assignment submission has 5 columns. Student has 3 columns. Okay? Notice there's also a key sign next to AID, a key sign next to SAID, and then another key sign next to SID. What are those key signs? Yes.
Are those the primary keys?
Those are the primary keys of those the tables, right? So the primary keys are not avoidable. Like when you have a primary keys for your design, when you're designing and drawing data modeling, which will be on the exam, unfortunately, you must at least have primary keys. Now, in some databases, if you use MySQL, I think it comes with relational modeling diagram in there. It's called reverse engineering. Using MySQL, if you create a table first, you can actually go back and create a diagram and drag and drop your tables. It's kind of reverse. Like you create a table first, then you draw the diagram. But anyways, if you're just meant to draw diagrams, some of those platforms will have foreign keys also. In this case, the SQL doesn't have foreign keys, but it has primary keys. So at least you need to put primary keys in your exam. And I don't need you to draw out that keys. You don't have to all draw that. You just put PK. Okay? So whatever is in this chart here, you see table names needs to be there. Columns need to be there. Data type needs to be there. Keys needs to be there. Primary keys at least. The primary keys, instead of drawing the key, don't waste your time drawing the keys during exam, please. Write PK next to it, that's fine. Okay? But last but not least, don't forget the cardinality. There's one to many in here, and if you draw it like this, that's totally fine, okay? Like, I will know it's one to many. I'll let it be. Okay? You need to have the cardinality. So, this is the most simple relational data modeling diagram. Okay? And to you, what's your name at the very end? Next to you. Yeah, you see, previously you asked me to draw that table. Remember? Yeah. Those table doesn't show your primary keys. This diagram does. It shows the relationship in the primary keys. You will never be able to see when you're running select query specifically have any like highlighted for primary keys or whatever. It doesn't in the database. Okay? Now, here's if we revert, once we have this table, once we have this diagram, and this is a very, very brief example here. Let's say when we come here and then we say students have the assignment. And then we want to design tables that track students and all their assignments here, right? And we know that student and assignments, what kind of relationship would it be?
One to many.
It would be one to many?
Yeah.
Which way one?
What is that with the student?
Okay, so one student can will have many assignments. So each assignment can only be assigned to one student. It will be many to many. Students and assignment is many to many, right? And look at this diagram though. Eventually, look at this diagram. Do you see a many to many cardinality here? No, right? You see
One to many.
You see one to many, you see two of them, right?
One to many, many to many.
Yes, so you see, you don't see a many to many cardinality, you see a one to many cardinality. And this is why we are going to have to talk about normalization. What time is it? Okay, we have 15 minutes, we can talk. This is the part where we segue and talk about normalizations. Okay? Now, think about this. Okay. Think about students and assignments. Let's say if I wanted to put assignment ID and due date. Okay. For example, like this. Let's say this is where we end up being there. But let's say if we know that student assignment, their relationship would originally be many to many, right? That's it, many to many. How would I be able to put the many to many, display that to the table? With primary and foreign keys. Yes.
One student, you list all their assignments, or you could list it the other way where you have the assignments and all the students that have to do that assignment.
So, meaning like, you have
If you student name, then you just sign.
why don't we try the student parts? Oh, I don't know if that's easier or not. Are you saying that, for example, I will do student 1, student 2, ID, like that? Adding more columns here? Because how would I do foreign keys and primary keys here if it's many to many? Is that what you're saying?
I'm saying like, you have a student ID that's the column you're cutting, but then you have multiple instances, so like, of the assigned. Or not assignment, multiple.
So one column that has a list of assignments in the student row. Is that what you're saying?
So you have assignments, we have multiple instances of the same assignment, depending on how you're joining. So you could have the same assignment multiple times.
That's not
What was your question? But then how, so you're saying that this way it will be 0, 1, 0 again, and then there's student 2's like 3, 4, 5, 6, and then 1, 2, 3, 4, like that? So you see like you're talking about multiple assignment and different students? But then this is primary key. That's duplicates. That's not allowed, right? The other way is, so this is not allowed, we know that, right? Is anybody not clear why this is not allowed? So if I'm trying to attempt to display the many to many relationship here, and then I want to say 0, 1, 0, 2 times because the same assignment, but assigned to 2 different students. I'm trying to do that. It's not going to work because this is primary key, right? It shows up twice. That's first thing. But this doesn't work. Another way that I was thinking about, I thought that you might say, is that I have multiple student columns. S1, S2, S3, whatever. All foreign keys, whatever. And then I have,
Pretty.
yeah, for each of them, it's the student, whatever it's submitted. That's one possible solution with multiple columns of foreign keys. Anybody following what I'm saying? So you have the same assignment here, but you have multiple student columns. And then another way, yeah.
The other, the opposite.
The other way it also works too, right? If you don't have it, and then you have assignment here. Assignment 1, assignment 2, and then blah blah submitted or not. Yeah. That's another way. I mean, either way, whichever way, we're many to many relationship. That's one of them. And then third one, some people might think is, why don't I just create one assignment here? Right? And I'm not trying to foreign it, but I have a list of 0, 1, 0, comma, 0, 1, 1, comma, 0, 1, 2. But I'm not creating any foreign keys in here. I have primary keys, yes, but I'm not having foreign keys. So that's, if it's many to many, the first option doesn't work, right? We know first option doesn't work because then you show up multiple times with primary keys. That doesn't work. The other two option, potentially, that database will at least let you run is that you have multiple columns with S1, S2. And then the assignment, or another way is having one almost like an array in here. Okay, so I'm going to explain two different ways that these two other alternatives wouldn't cause an error per se when you run it. The compiler wouldn't let through an error. It would run, and you can store database like that. But it's going to violate normalization rules. Okay, when you violate normalization rules, there's one normalization form, second normalization form. Each form gets more strenuous, more events, and each higher number always have a prerequisite that it has to be the previous one already to be able to build up the normalization form. But normalization does not impact on runtime or compile time. It does not, meaning that normalization is not a strict constraint like keys and stuff that will throw in error. However, why do we need normalization? Because we want our database designed so that there's no slowdown of speed, no redundancy storage, or abnormalities. When I talk about abnormality is, think about this. As we know array, right? We know arrays, and we know data structures. When we have arrays or when we have data structures, that means that we set a space for them. Right? We set a space for the data structure. But in this example, students and assignment, the students submit every single assignment? No. Not necessarily, right? So you end up going to have data structure in here that have 3 values. Some of them have 1 value, some of them have another 1 value. You already reserved memory space for 3, but you end up having some only have 1, some have 2. Okay, that's number 1. Number 2, when you're trying to join, let's say on the assignment ID, you need to think about what you have to do is first, you need to read through a string. You need to find a comma, split that into 3-value array, then you're doing the join. Okay, if you're in the bank and then you need to process millions of rows in a minute, is that efficient? No, it's no, your whole indexing, your whole hash table is demolished. you need to first do a string split or a string split into array and then read off one array index 1, array index 2, array index 3. Your database is not going to run. Like your ATM, someone go to your ATM, it's going to take an hour to go through the next screen, right? Abnormality. So those are the problem here. You're storing these columns for possibly no values or missing values that you're wasting memories. Secondly, if you're storing it using data structure, you'll end up, again, wasting memory. On top of that, slow down the join operations or union operation or whatever operation that, especially in here, you're trying to reference something. It's likely that you're going to use it for some relationship. Okay, so let me rephrase. What normalization do is that it helps when you're designing a table. You first defining all the actions that you want, right? You define all the columns, you're defining all the data types and the keys. After you have all the definition, the second part is when you're kind of making the cardinality, or you're kind of thinking about where I should put this column, or whether or not it should be a many-to-many, or dissect that into two one-to-many. This is when normalization comes in and trying to help you, save you from those redundancy, waste of memory, or waste of time. That's what normalization do. But normalization is not strict constraints. I want to make sure of that. But normalization has different levels. It has first normalization form, second normalization form, and third normalization form. You should, firstly, before we talk about each normalization form, you should know this, is that when you're trying to design the database in this course, or when you're graduated and then one day you do happen to design another database, you need to find a balance. But when it's too normalized, there you can normalize like 6. When it's too normalized, what it end up happening is you might end up, when you need to actually query them, you might do too many joins. Remember, you guys should have one of the lecture notes that has this processing time on join and union time and all that time, right? Join is very commonly used. One of the most commonly things to use in SQL. Sure, because the relationship is all about join. But having too many join, they are expensive. When I talk about expensive, meaning time consuming. When there's too many joins, too many, each normalization are going to make your table more modular. Just like when you're coding, you're making your code more modular. Sure. But then there's a lot of object and referencing methods you're calling back and forth as well. So the balance normally, mark my word, is normally around 2.5 normalization form. We will be focusing mostly on up to 2 second normalization form. At the end of semester, we're going to go 3 and 4, but your project stops at 2. Okay, now, what is the first normalization form? The first normalization form should meet the first normalization form is no mixed domains, no duplicate columns, no multiple values in one column. Okay, do you see the very last one here? Okay, if you're a first normalization form, this already out of question. Right? Multiple values in one column. First normalization form. Okay, no mixed domain, I'll explain. No duplicate columns, I'll explain. No multiple values in one column. This will ultimately not, okay, you can't have that if you want to be first normalized. That's number one. Let me explain what no duplicate columns. What it means here is not actually duplicates. Like you can't have duplicate columns to run and create a table with duplicate columns. Anyways, what it means here is that you shouldn't have a student 1, student 2, student 3, student 4. Like that, as a pile of data structure columns. Okay? You might ask me, what about mom and dad? Or like parent 1, parent 2? Okay, fine. That's kind of exceptions. You know for sure that the number is at most 2 and most likely either 1 or 2 or at most 2. It's not expendable, unlimited, extendable expenditure. May be acceptable, but you should not have something like assignment 1, assignment 2, assignment 3, assignment 4, assignment 5. Even though they're actually named differently because they have the number behind it, but they are considered not in compliance with first and F. So this is out. This is out. Those two are out. Okay? Remember, those two are out, and we're out of actual options. So later on, this is where we're going to find how we slowly move into that 1 to many times 2. Okay? The last one here, no mixed domains. This no mixed domains is a little bit tricky. The definition of no mixed domains, it means, pay really careful attention. No mixed domains, meaning like, if your, for example, let's say if I have a, website for students, each student, let's say they have their own profile website. Okay? What no mixed domain here is that, let's say www.ccmy/Shane here. And the next one is Shane at citymail.cuny.edu. What mixed domain is you're using one column to store homogeneous information. You're not sticking with your original, you're not consistent with your values type, even though they're both strings. But domains is less strict as type. It's more like definitions of the value information. That's what mixed domain means. Meaning like you should not store different domains using one column to store different domains. Okay? If I want to store URLs or websites, I name it web URL. There's nothing wrong with it, but don't, if you want to be first normalized compliant, don't put email in there. Like, or you put a phone number in there. I mean, it's going to work, right? Because they're all string, data type wise. In the database, it's going to run. But it's a violation of compliance of first normalized form. Right? So let me rephrase that. Will it run in SQL? Yes. It will run in SQL, but it's not recommended. And it's not in compliance with one event. And if you're not compliant with normalized form, what will happen? Your database is still going to be there. But the more and more of these like abnormality adds up, slows down your database, and then you get into these problems like I previous example mentioned, right? You're stacking up all these abnormalities and slow down your database, and let alone like we are looking at all these examples. You're thinking that that's not huge deals. You need to think about one day your row size is multiplied by millions. That's number one. When you do join, it's crazy. But don't forget, your columns could also be multiplied by thousands. And sometimes when you look at a table and then you build it this way, the second person that one day become your junior may create a couple more. The one that after him would not know what you had created. How would he know you have 5 different assignment columns? Right? If there's thousands of columns. That's why like if you're saying that they are all second normalized compliant, or first normalized compliant, it will follow certain rules of your database so that it doesn't add up these. I guess you can call it technical debt too, right? Do you guys know what technical debt is? It's all these bugs that you're trying to push it on your Jira tickets to the end to fix one day. And it adds up one day and it's just break everything. Okay, so what time is it? Okay, almost done. Well, after the second oral form, we'll probably can summarize up. The second oral form. So the first one, let's review the first one so we all understand. The first oral form is no mixed domains. Mixed domains is if you have a column and a certain data type you're storing for certain information, keep those information consistent. All right. Even though it's all text, varchar 50, don't store phone number if you're trying to store a website. Don't store email address when you're trying to store a phone number. Okay? No duplicate columns, meaning like don't have these seemingly data structure, but on the columns. Okay? Like assignment 1, 2, 3, or like sister 1, sister 2, student 1 or student 2, 3, 4, 5,000, whatever. Don't have that. Last but not least, no multiple, meaning don't have things that you're trying to store repeating multiple numbers or like data structure, array, string, or even created like a tree in there. Don't do that. That's first normalized. Now, does this say that anything about null or not null? No. Remember, null and not null has nothing to do with first normalized form. You can still leave the data after you create a table, you can still leave it blank or null. It has nothing to do, but it's how you design it and then populate and then adhere to the normalized form. Secondly, no partial ID. Okay, what is a partial ID? So partial ID, slightly more tricky. Partial ID means that you have a combo primary keys. And what is the best way to describe this? You have a partial primary keys and you, let's see. What is the good? Let's say course ID, section ID, course name. And then details or summary and instructor. Okay, let's say if you're looking at a class, and then this class is csc336, section 1, csc336, section 2, csc460, section 1, course name is database, intro, and then this is database intro. And this is data science. Summary, blah, 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 blah. Intro, DB, intro, DB, intro, data science, slang. Okay, so in this case, this is the combo key here. Right? In this case, if I have a course list of courses that is offered this semester, I mean, there could be many, multiple rows. And then if I'm trying to find a primary keys in here for courses, right? I will likely pick course ID and section ID as combo keys for primary, right? Because if I just use course ID, it would just be csc336, and there's multiple of them, so I can't do that, right? So I'll use section ID and course ID together as a course listing table, primary keys. Now, what partial ID meaning here is that in some cases, and especially in this case, you can see that when it's csc336, doesn't matter section 1 or section 2, the course name is always going to be database introduction. The summary is always going to be introduction to database. Now, instructor might be different, right? Instructor might be different. But having course ID, CSS336, we already know that it's always going to be the same course name and going to be the same course summary here. Do we need to know the section 1 or section 2 to know that? It doesn't. Right? So when that happens here with what we're calling there's a partial dependency, whereas partial ID is showing in this table. And what we need to do in that case is that for second normalized form, we need to take that partial ID out by its own on its own table. So it will look like this. You're gonna get let that intro to USD here like that. Okay. So you need to basically when there's partial ID, now you have to break the two and make the one that has a partial ID a tendency into its own table. So as I mentioned earlier, the summary and the info of the course will change or stay the same just based on the course ID, right? It doesn't matter your section ID. So basically over here, you will have your own 336 here that's already managed to tell you the summary here and the info here, right? So the primary key here could be just the course ID in this table. In this table, let's say this table is the actual course table. Okay? And in this case, you can have something like this. And CSC336, section 1, and Sheng, let's say. CSC336, section 2, let's say a hero. Okay? Second normalized form. Anybody follows? Okay, we'll end here today, but let's let you guys think about this, review a little bit. We're gonna come back and continue and expand a little further and then do a little practice next section. But go home, I know that this is newly introduced, go home and digest that a little bit. Think about what I taught you guys today is first normalized form and second normalized form, and have it internalized to you, okay? All right, if you have any questions, you can stay behind, otherwise, I'll see you next week. And there's no live section tomorrow for the people on Tuesday.
Professor, thank you so much.
Thank you.
All right.
There's. You can't.